Let's do practice problem number 2 right here. It says an 8 Newton weight has one horizontal rope exerting a force of 6 newtons on it. And we want to know what are the magnitude and direction of the resultant force on the weight, and what force and direction is needed to put the weight into equilibrium. Okay, so let's, this is practice problem 2. Zoom out. Okay, so practice problem 2, and this is on page 151. So given, well, we've got a weight, an 8 Newton weight. We'll just draw it as something that looks like this, some kind of a weight. And it has a weight of 8 newtons. So I'll just write that as mg equals 8 newtons. And it says has one horizontal rope exerting a force of 6 newtons on it. So we're pulling on it with a rope, and that rope has a force of 6 newtons. And we want to find A, the resultant force, and B, what force, it says, what force is needed to put the weight into equilibrium. Now we call that the equilibriant, right? The equilibrant force. I'll call that F sub E. And it's the force that I'm going to use to cancel out these two other forces, to keep the object in equilibrium. So let's solve. Well, the resultant force is really when I add force 1 plus force 2. I'm going to add the two forces. This is just like assignment 1. But but this really, instead of F1, I'm going to call this mg, and I'm going to call this the applied force, I don't know, or the tension force if you want. But remember, this is a vector equation, so let's add them up. I'm going to do this. I'm going to say mg plus the applied force is equal to my resultant force. But I've got to get these in rectangular coordinates before I can add them. Whenever you add vectors, put them in rectangular coordinates. Well, what is the weight in rectangular coordinates, right? Look, rectangular coordinates, you got an x and you got a y component. Well, let's mg. What's the x component of this? Huh? 0. It doesn't have an x component. Gravity does not pull us to the side. All right. And then we know that this is 8 newtons. But in what direction? In the negative y direction. And then Fa, or the applied force, or the force of the rope, I could call it the tension force. Look at the picture. This is really a free body diagram, isn't it? They give you the free body diagram. And so it's 6 newtons in the positive x direction. What is it in the y direction? 0. Add them together. 6 newtons in the x, negative 8 newtons in the y. Now, we can now figure out what the magnitude and direction of FR is. Equal to, let's see, this would be 6 newtons squared plus 8 newtons squared. I don't need to put the negative in there because it gets squared away. What is that equal to? Let's see, this is 6, this is 36 plus 64 is 100. The square root of 100 is 10. And what's the angle? Inverse tangent of negative 8. You need to keep the negative to find the angle, divided by right? And what do we get for an angle here? Negative 53.1 degrees. Okay. So we can say, all right, the resultant force, the force I get by adding these two is 10 newtons, negative 53.1 degrees, and there we go. Put a vector head on there. Does that make sense to everybody, what I did? Okay. Yes? Why did I not add 180 degrees? Okay, what is the rule for when we should add 180 degrees to our angle? Well, in order to need to add 180 degrees, this needed to be negative 6 newtons. If the negative component of your resultant force is negative, that means you're either in the second or third quadrant of the XY plane. Your calculator doesn't deal with the second and third. It can only give you an answer that's in the first or the fourth quadrants. So if you're in the second or third, you have to know that and just add 180 degrees to your answer. Now, so let's take a look at the picture here. Let's just add it to what's, well, I'll draw a separate picture so we don't mess up what's given. Here's my weight. And we said, okay, we got these two forces acting on it, 8 newtons, and then 6 newtons, like this, right? Now, what do? We added these together. So you go, I'm going to add two vectors. What do I do when I add vectors together? I hook them up head to tail. So I'm going to take this 6 newtons, I'm going to, so this is 8 newtons, this is 6 newtons, and here's my resultant. There's my resultant force right here. And that's about the right angle, isn't it? That's 53 degrees, 53.1 degrees and everything. So it matches my answer. That's good. See, it's negative. It goes down like that. Now, this is the result of these two forces. What do I have to do to cancel them out, to keep this object in equilibrium? If I want to apply one force that's going to cancel that out. Well, okay, this is this force right here. If I want to cancel out this force, this resultant force, what do? Pull in the opposite direction. Right? If I want to cancel this out, so I just need one force that goes like that. So what do? I say, well, it's the same magnitude. The equilibrant force will have the same magnitude as the resultant force, but what angle does it have? What's the direction? You got to add 180 degrees, and what do you get? And that's all there is to it. So if you know the resultant force, figuring out the equilibrant force is pretty easy. Okay? You just have to, and by the way, this is all very visual, isn't it? Drawing a picture of it will help you solve the problem. So, draw lots of pictures. That is all.